Hello and welcome to the Rust Maven meetup. My name is Gabor Szabo, as you already know probably. I'm going to present a little bit about reading JSON files in Rust. My background is that I've been programming for like 40 years. I've been teaching programming for 25, mostly Perl and then Python. And for about a year, I've been working with Rust as well. So in this presentation, we're going to see how to read some JSON files, not everything. We won't deal with everything. Actually, I asked before the meeting people what kind of JSON files they might want to read. I haven't received any responses, so I'm going to deal with the ones I have or the basic things that I have. And then if you have any questions, you're welcome to ask in the chat room. And that's it for now. So let me share the screen. And hopefully you're seeing, let me check what's going on here. Okay. So hopefully you are seeing the web page of Meetup. Please confirm in the chat if you see that and not the other screen, because that would be unfortunate if I was talking about one screen and you see in another one. So you can see the Meetup page where we have this information about the meeting, and I have another page which is part of the slides. I'm going to copy paste this into the chat room, and it will appear underneath the video, or link to it will appear underneath the video. These are part of the slides I put together slowly for my full Rust course. And so this is the part about JSON. And in order to read JSON files, there are various, I guess there are various ways to read JSON files in Rust, but mostly the standard one is using Serde. I think that's the way people pronounce Serd or Serde, which is a library. Let me actually visit the website. So this is the website of Serd, which is a framework, okay, for serializing, deserializing all kind of data structures, not just JSON. You can deal with YAML files, TOML files, I guess all kind of other files as well. I've been using it primarily for JSON, and actually for JSON, YAML and TOML files I've been using it. And this is the main library, and then you have implementations for the various data formats using Serd as the, let's say, backend or the framework. So we are going to use the Serd JSON and the Serde _JSON crate that I linked also in the slides. And once you have the link to the slides, you will be able to also get these. So these are the two crates that we are going to use. Actually, this is the link to the Serd crate on the, not third, like the Serde crate on crates.io. Okay, the other one was just a link. What you will generally need is to add Serd JSON to your crate that you are writing, that you use to read the JSON file, and you will also probably need the Serd JSON, and with the derive feature. Okay, so you could add this with -- feature derive, or just that way. But these are the two things that you need in your crate. Let's get started with the first thing. So here, maybe I enlarge a little bit. Just a really little JSON file, and it's well formatted, or it's readably formatted in this case, so we can read it. Of course, Rust doesn't need that. It could be just one line or so. So it has some key values. These are numbers. These are strings. And you can think about, in general, a much more complex JSON file as well. But let's get started with something simple. And as I said, we need the dependencies, these two dependencies that We can add them with those commands that you saw in the first page. But eventually, that's what we will get in the cargo toml file. So you have a crate. You created a crate. In this case, this is going to be called read simple JSON manually. That's the name of the crate I created. And the cargo toml file already has these things in there because I have already added them. And the very first version is I say, okay, I have no idea really what is the internal format of this JSON file. I don't want to describe it. So what I'm going to do is I'm just going to read it. And for that, I have this code. So I have the name of the file. I get it from somewhere. Doesn't really matter. Here it's hard-coded in the application. And then I can use from the standard library, I can use the read to str function that gets the name of the file and will return a result, which can be either some error message if the file didn't exist or whatever. That's just plain reading the file, or it can be the content of the file. Now, I didn't want to invest in error handling here, so I just code unwrap, and this is how I get the content, assuming that we can actually read the content of the file. Nothing to do with JSON yet at this point, so just content of the file. And also, I think the recommendation or the more standard way is to use stdfs and then here at the top of the file. So basically to map the fs name into your namespace, into your crate, and then call here fs read to string. I sort of not really 100% sold on that idea yet. So here in this case, I just code with full pass. So I don't need to use, but I have the full pass of this function, gets the name of the file, returns the content of the file, which you could see there. And then I code a third JSON. Again, I don't set the use, so I have to put the full name of it from the str. So here I assume that I already have the content in some variable. And because it's reading an str, I pass into the ampersand content, so not the content itself. I basically let it borrow it. And again, this one is already parsing the JSON file, the JSON structure. Sorry, it doesn't really know that it comes from a file. And so it returns again a result, which can be either some error or the parsed structure. Okay, but what is that structure? That's a big question. So in case of an error, I put here an expect and some error message. It could have been just unwrap. I don't really know why I put here expect and here unwrap. Doesn't really matter. Neither of these are really good in production code, right? But I don't want to deal with that. So what do I get if it's a successful parsing? We don't really know what kind of structure is there. There can be any structure. So there is a generic struct. I think it's an enum or a struct. What is this value? Third JSON. Let me look for it. Okay. So this is the thing. It's an enum. Okay. It's an enum that can be anything basically. Okay. That's the whole point of it, because you don't really know what is there. It can be like in a JSON. It can start with what we would call a hash or a dictionary, like what is it? Sorry, let me get back to this. So this is I think it's called an object in JSON in JavaScript at least, but it looks something like a hash or a hash map in Rust or a dictionary in Python. But it could also be a list, so it could be starting with square brackets and thing. And internally there could be anything here. Any type of value there could be here, okay? Numbers, strings, arrays, whatever. So this value thing has to be able to represent everything, because we didn't tell it what is there. So that's why we expect it assigned to the data, which is this type. Fine, and then we can print it out with just print line, and this is what we get. Okay, so it will print it out just as it is. Okay, it will look like exactly as the original data. And now, because we didn't map yet anything, we basically need to somehow get these fields. And obviously for this, we already have to know that there are fields called text and X and Y, and then we can call the get method on the data and now check whether it's none, so whether it's empty or there's nothing. And then here I just code panic. Okay, again, not really production-friendly code, to say the least. And here I said, okay, now if I have a value, then I convert it as a string because it's the text. I know it should be string, so I'm converting into a string and hope that it will work. Now with the X, I'm converting into an I64 or some other integer, of course, you could convert. But the point here is that I didn't have to make any preparations for the data structure. I don't have to care about anything before I parse the string. And then I can pick and choose each field that I'm actually interested in and write a match statement to extract that data into some variable, and then it will be assigned, or in this case, panic. And of course, there is a lot more interesting thing to do with this. What is, I don't know if it's interesting or not, but because we are converting it into an I64, it's already a number, an integer, so we can do the mathematical operations on them. Okay, that's the basic, very simple one. And I first read the file into a variable and then parsed it from string. A much better way, probably, but more involved way to parse your JSON is first to create a struct that describes the fields and values of that JSON. And still we are this very same JSON file, but which is very simple, just one set of key value pairs, or just key value pairs. And so we create a structure where we define that we have an X, and in this case, for some reason, I use I32, not what was earlier, U64 here. I used I64. Okay, I use I64. At the end, it's up to you or up to your expectation of what kind of numbers are there. Okay, so without looking at the JSON file, this is the question. Without looking at the JSON file, how can I import it in Rust without knowing the structure of the file? So this is basically the first thing, the first slide or first example. This is the reason I started with this. That with this code, I imported all the structure I read and parsed all the structure into Rust, into a Rust structure, in this certain JSON, and then I can go and pick one of the fields, and maybe I can. I don't know if I could actually ask this data thing, what kind of values do we have there? What are the fields and so on? I don't know if you can do that because once I started to do this, I understood that it's way too much code, and it's much better if I start mapping the fields with the next example, okay? But if you don't know, and so this is how I started. The first thing I said, okay, I'm just reading it. I have no idea what's in there. Let's try to use it. And you can do that, and then that's how you do it. But once you know a little bit about the structure, you can create, the structure of the JSON, the fields of the JSON. You can create a struct that will describe that JSON, okay? And whatever name you give, okay, that's fine. And here I'm describing the fields and the values of that JSON. Here I just use two numbers and the string. So I described it, and then what I need to do, this structure, to make to allow basically the third JSON to read into it, is we have to put the which one? The deserialize flag, because we're going to deserialize the JSON string into this structure. We also I also added the serialize I derived from the serialize, both are coming from CERD, okay, from CERD. In order to, I think that, I'm not sure if I need it actually in this case, but because I think the debug might be enough. But well, anyway, we can try it. Okay, I'm going to try it now. Okay, so this was the read simple JSON to struct example. Read simple JSON to struct example. And what I wanted to try, if I can do it without the serialize one as well, I'm not sure. Cargo run. Okay, so yes, the serialize is unnecessary for this example. It's a leftover from the previous one, so I can clean up this code now a little bit, and then the slide will be updated. Okay, so this works without the serialize part. Okay, so we need the deserialize in order to be able to convert the string into the structure, and I needed the debug so it will be easy to print it out. Okay, otherwise I would need to print out field by field. So I have the file, I read the file again the same way exactly. I have the string now, and I have this example because maybe the JSON for you comes from some other source and not from a file. And so what happens if you already have the JSON string in memory? And then you can use the third JSON from string again, exactly the same, passing into the content and unwrap in this case, but you're assigning it to this structure. Okay, so the definition of this variable uses this structure as its type, and then that's how it created. So now we are creating an instance of the structure point using the data from this JSON. And as you can see, this is what is printed out. This line, this prints it out. And then I can access the X and Y, and I can also use them in computations because they were defined as integers and so on. So the question is, would it be okay to implement my own display trait instead of using the debug trait just to reformat the response data from the JSON? Yes, of course. I used the debug trait because I was lazy. Okay, so you can implement anything on this struct. It's just a generic struct. The only extra thing it has basically or needs to have for us is the deserialize to derive from the deserialize trait, so it will be able to deserialize. So we will be able to deserialize into this struct. Fine. Okay. So we have a very simple example where we described all the fields, described all the fields of this JSON. We'll need to do a little bit better, but before we do a little bit better about the JSON, I have two or one more examples, maybe two. Actually, this is already, okay, so I'm doing two things at the same time, but it's fine. We have a file called person.json, which is a way more involved JSON already. Some key value pairs, some of them are already, this is a Boolean, this is a floating point. Here the value is a list, okay? And here the value is a list of additional, what shall I call them? Dictionaries, hashes, objects. I should actually look up what is the, when I was teaching Python, I told people that these are dictionaries because that's clear for everyone. But I guess in JSON, they are called objects. Anyway, same cargo toml. I could get rid of this one here from in the slide. That's fine. So what can I do here? Now, what I do here is so I went back to the first example where I didn't specify any structure for it. I just read in the thing. But in this time, instead of reading in the content into an internal string, I wanted to pass it. And where is it? Yes. So third JSON, instead of from str, I call it from reader. And what I pass to it is the file handler that I got from file open. So it's more complex. It's written in a more complex way. I don't know. I started with this before I found out about the easy way to read a file that you saw in the previous example. But you might prefer to do this for whatever reason. So I think the previous examples were easier to understand and use. But anyway, in this one, I'm opening a file, and if it failed, then I handle it. I don't know. I report it and then do something with it. And if it managed to open it, then this file is the file handler, and then I pass the file handler to this from reader, and then it will read the file and process the JSON, or yeah, and assign to this data, which is type cert JSON value, just as we had in the first example. If I could cover how to fail graciously, maybe it would be nice. Once we covered all the reading part with these errors, nasty errors ways, then we might go back and implement one of them or change one of them to be nicer. Okay, but let's get over the JSON part. Okay, because I assume sort of that. In general, so this is orthogonal to the JSON reading part. You should be, or you are expected to be able to handle errors regardless of actually reading JSON or not. But yes, I would, at the end of once we finished all the JSON parts, then we'll can try to do that as well. Okay, some leftover from just debug message, doesn't really matter. But it can print out. So let's fix that, okay? So we can see this. It's called read JSON from reader manually, okay? So this is called read. I have brilliant names for these crates, like read JSON from reader manually. And I called it manually because, well, because it's not, let me open this one with the editor. With not with Vim, but with Visual Studio Code. Okay, so I wanted to, first of all, I can run this here, cargo run, right? And I'm in the wrong folder for some reason. Very strange that this opened in the wrong folder. Read JSON from read manually, read JSON from read manually, okay? Cargo run, okay, and I need to give it the name of the file, which is here person JSON. So this is what I got here now. This is the debug message, and let me fix that debug message because I don't want the debug message here. I would prefer that it's going to be a print ln, and then I would give it something like this. Sorry. Right. Let me run this again. Okay, now we have everything, and then I can output it to the out file, which will become the slide. Because now, if you go back to the slide, you can't see this output. So anyway, what do we see in the output? Let me get back. So we read this whole data structure, and this is what we got. Okay, this is the whole object. Okay, that was converted. That JSON file was converted into this because we didn't define anything about this file, about this structure. So this is the representation internally in Rust. And if you go back to the source code, what we have more here is basically I'm showing you how you can get each field. Obviously have to unwrap because it's unclear if it's there, convert it into a string, and then we can compare it to the real thing. Here we are converting to F64. Here we are converting into an array. Somewhere there was a Boolean as well. I don't know where it is. I guess I missed that one here. in the data, I think there is a Boolean, the married one, okay? So we can try to add this one. Let me try to add here in the code. So this should be something like assert. Actually, then I probably need to do this, right? I don't equal, but married s. No, it doesn't have s Boolean. Does this work? Let's try to see if, and if not, then I will. Of course, that's not date, that's data. Okay, maybe it would work much better if I were typing it correctly. Okay, so now this worked and it actually checked whether it's true. Okay, so it's fine. Output is the same because that didn't change. So I added, and it will be added to the slide, the new version. And here I'm using assert instead of assert equal because I'm not comparing. Maybe I could also say assert equal and check if it's true. Does it work? I don't know. Of course, I need to add the comma here and not. Oh, well, that's also good. I'll have a comment here. Maybe use assert. Just so other people won't tell me that it's an assert. So anyway, that's the main thing that you can okay. So here this code is just getting from the command line the name of the file. Okay, so that's not something very interesting. I repeated this code in many of my examples. So here we get the name of the file from the command line, and then we read in the file. Okay, or actually we opened the file and gave the file handler to this from reader. And as you can see, we got the structure, and then we can access the various fields without any description up front of the data structure. Now, what if we have the data structure? Okay, and so now I created a person structure where I said, okay, there is an F name, an L name, and the field called married, which is a Boolean. But as you see, if you remember, of course, it has a lot more fields. So what will happen now? And in this case, what I did is get the name of the file, and I read from reader. But this time, I wanted to convert it into a person. So not just a generic value thing, because now I already described at least some of the fields from the JSON. And what I get back is that it can read the JSON, it will disregard all the rest of the fields and fill the fields properly. So that's the first sort of step. If you don't know anything about your structure, you could actually even start with an empty structure, I think, and deserialize your JSON into that structure, and that's how you can get started. Okay? But of course, it's better to start adding fields. You don't have to add all the fields. Any questions? Just keep asking, okay? So that's fine that I don't have to add all the fields, but at one point you probably will want to say, okay, but I don't want to get all kind of extra fields. And actually, I think I should have shown this in a different way. So let's try to go in the different way. What happened? Anyway, don't worry about it. I'll go back. So here, this is an example of how to make sure that we don't have extra fields, so that we actually described in this structure all the fields. It will be clearer later on why we need it. But you can probably understand that you want to make sure that there are no various extra fields that your code doesn't know about. And the way to do that is rather simple. You add this third deny unknown fields, and you will get this panic basically on line 16. So basically there is this JSON parsing error. Okay, we got this except and some more error. So here maybe I should add the more graceful error handling to show you that it won't panic. It will just provide you a better error message. So at the end, we can get back to this and provide a, you know what? No, let's do this now. It's called avoid extra fields. That's the name of the it. Avoid extra fields. So let me open this one. And here we are. Okay. So now if I run this cargo run, and I think I need to also give it the name of the file, I get this panic. So what can I do here? Oh, and before that, actually, just let me show you something else. So in this case, I didn't define the data variable as having a person type. Let me go back to the slide where it's clearer. Here, I didn't say, okay, there's nothing there. Instead of that, I used the turbofish syntax, which putting it after the call. And so this is, instead of having here colon person, I have here double colon, and then in what is it called? The angle brackets. I think that's called angle brackets. I have the person, the name of the type, okay, of the structure. So this would be the same as putting here the dot person. Actually, I think I prefer this syntax, even though it looks a little bit fishy, to say something, okay, whatever. But for me, it's sort of clearer that I'm telling the parser to convert to person instead of the data to be person, and then somehow the parser has to figure it out. Okay, for us it doesn't matter, but it seems to me clearer. So, but if I go back to the editor actually shows me that it's going to be a person. So that's why I wanted in the slide to show that there is nothing there. This thing is what just added. It's not added. It's just shown by the editor, in this case, VS Code. Okay. So now what we wanted to do is replace this one, I guess, with something like. So what should be the error? And this is always a question. Okay, how should we handle the error? Okay, what should be the case if there is a parsing error in this JSON? What should we do? And one thing could be, and this maybe not the best, is match. Well, you know, we could set a default, but I could say match, and then I can say if it's an okay, and then there is some data, then do all this coding, okay? So all this thing is in there. And if it's error, and I have some error message here, then I can print ln, there was an error, and then I can print out the ERR as well. I think that's going to be enough. And what shall we do here? Shall we go on running the code? So I mean, we can print ln, say, still here. Okay, so now I'm a little bit going into error handling, but whatever, let's do that. Yeah, let's try to run this. So if I run this, this is what I got now. I got the error message, okay, and then it's still here. So the program keeps running, okay. Now, of course, we don't have the data, so, well, whatever, okay. Yeah, I'm going to leave it here as it is now, and this is going to be the example in the new version of the slides once I update them, okay. Whoever asked it, was it okay, or would you like some kind of a different kind of error handling? Okay, there can be totally so many different ways to handle this. So this third from str, this call returned a result. And the result can be handled in so many different ways. One of them is this match. And then whether we could have decided that here actually we want to standard process exit one, because, and then I'm going to comment it out. So let me run this. Okay, so now we have the error message, and then we exit it, and then we can even show it that the exit code was 1, okay, which I set here. So that's a different way of handling the error. Okay, we didn't get the panic, but the program stopped because we don't have anything to do, let's say. But we could also set, let's say, a default values into this. So the match could assign actually back to some variable, and then we could set, in the error case, let's say, we could report the error and then set some default values, or many other ways to handle this. But that should be a separate video just about error handling, okay? Separate video and presentation. Oh, we are already 40 minutes into it, so way slower than I wanted. So this is how deny unknown fields. The order is not correct, because the first thing would be is to, okay, what should we do if if we are trying to read in some data, but the JSON doesn't. So we have the person defined, but the JSON doesn't have the fields. So some fields are missing from the JSON. What can we do? There are basically, I think, 2 or maybe 3 ways to handle this. One of them is to fail, okay, and I didn't handle that, okay. That would be I guess, the normal case, the default case. One that would panic, I guess, and or return a failing result. The other one is to set the default, and the third one is to actually mark the field as an optional field. So this one is marking the field with a default value. And the way we can do that, so what I did here is I said, okay, let's assume that I don't even need a JSON file. It's just an empty JSON string, which is a pair of curly braces. That's an empty JSON. And then I said that, okay, the person thingy, this person structure, has a field called fname, which is a string, and it has a default value. And the way we set the default is we add this annotation, and then this is a function that is supposed to return a string like this, okay? So it's it's a string. So here I implement it returns a string, and it will return just some string, okay? That's going to be the default. And the same way I can set, okay, get default, and here I could have called it get default married status or marriage status, but also I can call it get default false, and then I might have more booleans, and for some of them I put false, and for some of them I put true as default. So this is the way I can do it. And then I can run this code, and even though the JSON is empty, once I parsed it, and again I use the turbofish syntax, I get the person with the default values. Okay, so that's one way to handle missing arguments. The other, let's go. The order is not good. The order is really not good. Let's go. Let's find the. Okay, where is it? Oh, it's here. Okay, I just missed it. So what if if I would like to have some optional fields? So here I have a couple of different versions of JSON. Okay, one has a name field, one has a name and married field, one has a name and married and language field, and so on. And when this is true and false. And what I did here is I said, okay, the name field must be a string. Okay, and it's a required basically. The language field has a default language, and which is Rust. Okay, and the married field is an option, so it's going to be optional. Okay, and so if now let's go into this read with optional field. Read with optional field. Okay, so I can run cargo run, and I need to provide the name of the file. So if it's the just name, okay, just name, then what we get back is that we got back the name, the language was set to Rust because that's the default, and the merit is none, okay, because it's an option, so it's either none or the value. And in the code, we have, what do we have here? We have just printing out the data that you see, and then we have this match statement on the merit field, which can be either none or some value. Okay, and in this case, that value is a Boolean. And of course, here too, there are plenty of other ways to handle this besides the match. Match is sort of the basic way. So here, if it's none, then we print out this one. And if it's some value, then we are going to print out the merit status. And because in this case, there was no merit field, the field merit was not existence, it got the value none, and we say we don't know if foo is married or not. We didn't have either true or false there. And then we can go to the other one, which is another file, which is married but no language. And so here we get foo, of course, it's always foo. The language is set to Rust, which is the default, and the merit is set to the some value, which is true. And then the second part of the code, which is here, okay, this part, found that it's some value, and it printed out the value already, removing the sum part, so it printed out already the Boolean value. And if I go with married with Python, then it will say, okay, the language is Python, and the merit is true. And if I go to the last one, the single with Python, then the merit status is false. And let's say copy, which one should I try? Copy married with Python, no name, JSON. Let's create another version here. So here we are going to create a version where we don't have a name. So we have married status, language, and Python. And now if I run this code, or with this no name, then we get this panic, okay? Because we expected, and that's good that we have this, we said here that the name is a required field, okay? So we basically every field you define is required unless you set it, unless it has a default or it's an option, okay? And here we didn't handle anything, so we just got this expect JSON parsing error, which is what we got here, JSON parsing error, and then it also explained. So we can go back to this error handling, what we had earlier, and implement that if we want, but this is the point that this is a required field. Okay, sorry, the order, I have to fix the order. So read JSON handle missing values we covered, and the next one was here the read complex JSON. Okay, so it's basically what I did here is took that. Let me show you the file, vim person. So this is the person file, and we were dealing with that file a couple of times already. And I wanted to implement now the whole thing for this. So what I have here is the person that I'm describing, that it has an fname string and a name string, year, which is a U32 or whatever integer you pick. The height is some kind of a float. Let me just go show you. The height is some kind of a float, okay? Yeah, by some kind is 32 or 64, okay? Not that many choices. The merit field is a Boolean. And then the numbers is getting interesting because it's, as you can see, it's a vector of numbers. So I said here, it's a vector of U32s. And the children, let me get back here, the children is a vector, is going to be some kind of a vector of little objects, okay? Which have, most of them have name and a birth date. So the way we do this is that we create a new structure, or we do it that way, it doesn't matter which way you do, which also has basically the deserialize. We only have the deserialize needed here. We don't need the serialize, I guess, here. Okay, so I'm going to remove that later. But the point is that this describes a child structure, okay, which has a name with a string and a birth date, which is a U32. And then here I say the children is a vector of this child. Okay, and that's it. So now I can get the name of the file, read it as a string, and parse it with the turbofish to this content. I can handle the error if I want to, or in this case, I didn't want to. And this is what I get back. So I get back a structure, the data from a structure, and then I can assert certain fields if I want to. This is the way I can access the fields. It's just a regular structure now, okay, with substructures. So this is how you get the description of something deeper than just one level. Okay, something that I had to handle when I was I needed to handle it when I was writing a parser for the cargo toml file for the Rust Digger project. And so there are fields, for example, there is a field called Rust-version. So how can I create something for that? I can't define, and I just called it a thing because I didn't have a better idea. I can't define the field which is called Rust-version, Rust-version, because dash is an invalid character as the name of a field. So this I had to comment out so I can show it, but I can't use it. So instead of that, I need something else. So I say I can pick Rust_version, assuming that we don't need that for other purposes. And then I can set an alias saying that, okay, please, when you see Rust-version, then map it to Rust_version. That's it. So in case you have fields in the JSON that are not field names in the JSON that are not valid struct field names in Rust, this is how you can deal with them. Okay, and then you just read it, and this is what I got back. So the name of the field is actually Rust_version, even though in the JSON I have a dash. What else? Oh, another thing that I haven't dealt with so far. What if the JSON actually starts out as a list of things? So basically a list or vector or whatever you like to call of objects. And no problem at all. We described the structure of this single one of these. Okay, it has a string and a number, not very fancy. And when I'm reading it, I tell the turbofish that it's a vector of person. And so I get back this thing. And then from that point, you already know what to do, hopefully, that you have a data structure, which is a vector, and then you can access the elements of it, iterate over whatever, and access the structures in there. What else? Okay, so this is actually an error in the slides. What I wanted to add here is actually something that I haven't implemented yet, but apparently the slide doesn't contain the right file. It contains the main file instead of the JSON read list. This is what I wanted to show you, which is this is what I want to implement. I haven't got around to it yet. There are cases where we have a file which is just a series of JSON structures. So this is not a real JSON file. It's a series of JSON structures. As you can see, there is a JSON line here and another JSON line here. Why is it? Because sometimes people are logging. They use so this is sometimes used as logging, and logging just these JSON structures. And I wanted to be able to read it. I think I have a very easy way to do that in Python, and I wanted to figure it out. I don't have the solution yet for that, but I hope that some of you will send it to me, or I will have to do it and then I'll post it on the slide. And the last thing, basically, from the reading JSON part, it's actually something which is already part of the serialization part, so we can slide in there because, or whatever is the word, because we still have some more time. But I really wanted to know what to do with a hash map. How can I serialize and deserialize a hash map, which is, well, is just the key value pairs, where the keys are strings and the values are numbers in this case. So I don't have a struct for this. And so this is what I have. In the memory, I have a hash map, a dictionary for Python programmers, or a hash for Perl programmers, or an associative array for PHP programmers. And how can I save it onto the disk, or create or do something with it to format into a JSON thing? And so I can do is the third JSON toString. Okay, I provide it, I pass it the data. Okay, the variable. I have this unwrap, okay, fine. And I got back a serialized JSON string. So if I print this, the first print shows you the original data structure. The second one shows you the serialized one. So this is the JSON. And then I can deserialize it by saying third JSON from str once I have this JSON string. So at this point, I would either save it to a file or send it to the network or put it in the database. And some other program would probably read that from there and then want to convert it back to a hash map. So now somehow I get the JSON string from string str. This time I apparently used it here instead of putting the turbofish syntax. But oh, I have the turbofish here. Okay, so I have this version and the turbofish version. That's even nicer because you can see now both versions. They are doing the same, and this is what I got back. Okay, and the order, as you can see by chance, the order doesn't matter. Okay, so key value pairs are fine, but the order between the key value pairs doesn't matter. Okay, so I think this is how you serialize and deserialize hash maps. The rest of this chapter deals with serializing JSON, and let's go over, if we are already here and we have some more, a little bit more time. Here, what I have here is, I think this was the very first attempt of my creating a JSON file. So what we have here is we have this macro called JSON that comes from the third JSON thingy. And so I don't have a data structure here. I'm just trying to create some JSON. And I have variables, a string, a number, a vector, and something that has a time in it. And this is how I can serialize it, that I basically pass into this JSON macro this structure. Okay. And here I use UTC. So UTC is the timestamp. .timestamp in order to serialize it, and this is what I get back. Okay, this is what I got back. Okay, so this is the whole serialization. That's one thing. Now, if we have a struct already, that's going to be easier. Okay, so if we have a struct with some data, okay, this is the struct, and for this we need the serialize part. So earlier we needed the deserialize to derive from the deserialize, and again here some extra curly braces that are not needed. So there are some things that I need to improve with the slides. We created a instance of the thing, and then we can call the toString again on this, and it will convert into a serialized structure. That's it, called JSON serialized struct. So it's called JSON serialized struct. And so what do we need here? src main. First of all, I wanted to replace this debug with println, and have, I guess I need to put here something that will make it readable, okay? I wanted to get rid of these one because we don't need those. And the dead code here is because I think because I don't access some of the fields and Rust was complaining. Cargo run, okay. It's thinking about it, whether should it do it or not. If you have any questions already, then do it now or ask it now. Or if you have any JSON structures you'd like to be able to parse and we haven't covered yet, there are plenty, but if you have some, then please paste them now, and then we'll try to do that still in this video. So this is what we got back, and I guess I'm going to save this into this out file that will be included into the slides later on. This we got back the thing, which is just the original one, and then this is the JSON that we got back. Right? Another improvement, so not part of the JSON thing. I started out with these two strings calls back when, like, I guess a year ago when I created this slide. It's much nicer to write string from in these cases. ToString especially is specific to serialize, to stringifying things. If we do something, then it would be better to put here to owned, but even nicer would be just say string from, and we can run and we get the same. Okay, what else? Nothing else. This ToString is really ToString, fine, and right. Okay, that's it. I can also move this one inside. I prefer it this way. And I think I'm not sure if I need to borrow here. Oh, probably I do, because then I'll need it here as well. And I need to borrow here definitely. Okay, well, that works. Not necessarily have to borrow there. Cargo, Clippy, what does Clippy say about all this that I did? Clippy is fine with this, so it's okay. It's the Clippy in this case is very, very nice. Okay, I'm not sure what was this example about. This was there's some original things. There is a struct. It has a version of it. We convert it and we serialize it, bring the serialized version, and then we deserialize it, and then we have the deserialized version. So that's just a round trip example of the serialization and deserialization. And here I had, so this is I'm not sure if how good is this example. Here I have an object that was created with JSON, just this JSON thingy, and then I started to try to change that structure. Let's not get into this now. Yeah, okay, that can be interesting because this can be important. So how can you serialize a struct that has a date in it? And so we have a date time and a field which is called now, okay, which is a date time object, okay, an instant of date time. And date time UTC cannot be serialized by itself, but the chrono so this comes from the chrono crate, this whole date time thing. that the chrono create has a third feature. Okay, that's apparently it's a feature, and then I can, if I added that feature, then I can import it here or say use it, and then I can add it to be the serializer of this field. And so if I run this, let's go this JSON serialized struct with date. Oh, what a JSON serialized struct with date cargo run. It's fast. Okay, so now it's serialized this way. Okay, this is the original one. This is how it's represented in the object one, and this is how we serialized it into a timestamp in seconds. Okay, I guess there is TS milliseconds or whatever other things if you need, but this is how, or what if the way I could. Okay. The question is, if a crate implements another crate, example like chrono implements third, do I need to additionally import third again? So we imported third, actually the serialized part of third. And again, here I have these curlies which are unnecessarily. And yes, you have to import the serialized part. You don't import or the whole third. You just need import the serialized part, which is needed here because you want to derive from it. Okay, and this one is this is just so here chrono is only implementing the function that can serialize a date time object, nothing else. Okay, and this is the generic serialization that can serialize all kind of things, well, except date time objects, and except, I guess, a lot of other things. So okay, so this serialize is the generic. It's like the yeah. Well, yeah, I think the right things to say is the serialize is like the debug. It's implemented to a lot of things, but some things need to implement it. So it's implemented. Okay, it's implemented for the standard structs and types. Okay, the debug and the serialize, and then if you want to have it for an extra crate, then the author of the crate has to implement the debug, and most authors probably implement the debug trait, and some might also implement the serialized trait. I'm not sure. And in some cases, and I guess this is the case with the date time, you might have several ways of implementing the serialization, depending on I don't know what. Okay, so and here I think that's the point, that the date time crate says, okay, you can serialize it to seconds, to milliseconds, to I don't know what. Okay, and so you have to pick the one that's right for you. I think that's the story, and that's what we are done. The next set of slides is supposed to be about YAML. There's not much to say about that, and especially because we are not dealing with YAMLs now. And there is a separate part about TOML as well. In general, like by the way, the how you define it with the struct is the same, or hopefully they are the same. So whatever you learned about JSON could be probably implemented exactly the same way for YAML reading or TOML reading, with, of course, the various, I don't know, limitations or extensions of the various data formats. So I think that's it for today. Thank you for watching. Thank you for being here and asking questions. That's very useful, the questions. It enhances the experience for both you and for me as well. So it's really great. And thank you for watching whoever watching the video. Please like the video, follow the channel, join the Code Mavens meetup group. And that's it for now. Thank you very much. Bye bye. Yeah, last question. Are you able to share what you use and how you create the slides we are seeing on screen? Thank you. Yeah, so the slides um, are all I okay, so if you click on one of these links, okay, you have the link to the slides, but I'm going to show you. Then you actually get to the source code of that file in GitHub. The whole thing uh, is in this repository. I'm going to paste the link to the repository. This includes the whole Rust Maven website and the slides, the Rust slides. I'm still thinking if I want to keep them in one repository or separate them. I'll see them. But now they are the same, and they are all. There is a. Is there? Yeah, there is. And they are all hosted on GitHub pages. So actually, you can go to the workflows and see. I think this is here. No, this is just checking the slides. This is the CI. This is where we generate both the website and the slides. And the slides are using a Python project of my own, which is called SliderPy, and horrible project. Okay, actually, I think I'm the sole user of it, and that's fine. And they are generating the slides from these markdown-ish files. Okay, they are not really just markdown. They have some extra add-ons. I think they are actually what we call Markwa files, which are the file format of the yeah, this is a markdown extension format, Markwa. Anyway, that's GitHub, subgub, slider pie. That generates the slides from these markdown-ish files. So thank you very much for watching again, and see you at the next video. Where is the video?